we're going to talk about facility layout, and before we can actually talk about facility layout, we need to understand a little bit about the different types of processes that might need to be housed in a particular facility. And I'm mainly going to be talking today from the standpoint of manufacturing operations, though some of the same principles and concepts apply to service operations as well, but just for consistency I'm going to stick mostly to talking about manufacturing operations and therefore about making products as opposed to providing services. So the first thing I'm going to talk about is the product process matrix, which is a conceptual framework to help us relate how the products that we're manufacturing and selling to our customers affect the nature of the process that we want to use, a setup that we want to use to manufacture those products. After that, I'll talk about a couple different layouts then that correspond to the different types of processes that we might choose from. There's some layouts are called process layouts and some are called product layouts, and we'll see the difference between those two. And we'll also look at some tools for coming up with good process layouts and good product layouts once we've actually decided which type of layout is best for the range of products that we're manufacturing. And last but not least, we'll take a look at cellular manufacturing, which is an attempt to have a layout that sort of combines the best of the product and process layouts. It's sort of an intermediate approach which works well for a wide range of product types. So the first thing I want to talk about is this conceptual framework referred to as the product process matrix. This is the matrix right here. As you can guess from the name, what it's trying to do is relate the manufacturing process to the products that are being manufactured by the facility. So what we have in this matrix is this axis right here, this dimension right here, is sort of displaying product characteristics. In particular, product volume and product variety. So by product volume, we mean how many units of each type of product are we manufacturing? Are we manufacturing millions and millions of each type of product, or just a handful of each type of product? If we are a business that specializes in custom products for companies, we don't really make and stock anything. We wait to receive customer orders, then we manufacture products to those customer orders. We might have a very low volume per product. We might make something once and never make it again, or make a batch of something once and never make it again. That would be relatively low volume. Also, in that sort of business, we're going to tend to have a wide variety of the things that we make. So we would just make custom products for different customers, different manufacturers. We're basically supplying parts to other manufacturers, like say a part supplier to Boeing, and we sell not only to Boeing but to other manufacturers as well. And we're always getting new orders in, and every product that we make is unique and customized to that order. So that would be an example of relatively low volume per type of product and high variety. We're making lots of different types of stuff. We're basically a custom shop. Right? At the other extreme would be, say, a manufacturer of consumer products, say like a soda beverage manufacturer. They're making a certain range of beverages, Pepsi, Pepsi Light, Pepsi Free, whatever, and they're cranking them out in high volume. Those bottling operations, it's a massive production line just cranking out huge numbers of each individual type of product, but we're not making a lot of different stuff. Okay, we're making, different flavors of drink, but it's pretty much very similar types of product, just different flavors going into the bottles or into the cans. So that would be an example of high volume, low variety. So that's a very important dimension to understand if we're trying to understand how manufacturing processes can relate to different types of products. So this axis here, the horizontal axis, is the product characteristics axis. On the vertical axis, we have process characteristics. And here, what I mean by process characteristics is the nature of the process flow. Is the flow rigid? That means that every product that's manufactured, or every type of product that's manufactured, goes through roughly the same sequence of steps of operations? Or is the process jumbled? And that would be the case where every product that you make, or at least lots of the products that you make, they have a different flow or sequence of operations needed to make them. So take an extreme example. If you're making different types of parts, you might have a sequence for one type of part that first starts out in grinding, then goes to milling, then goes back to grinding, then goes to milling, and then goes to paint. You might have making another part which has a completely different sequence of operations. So in that sense, it would be a more jumbled process flow if you looked at the sequences for all of operations for all the different parts that you manufactured and overlaid them on each other. You get a very jumbled flow, whereas here in the operation with a rigid process flow, all of the parts are pretty much going to be, all of the products are going to be flowing through the same sequence of steps of operation. Okay? So the thinking is that these two dimensions, the product characteristics and the process characteristics, are very tightly linked in successful companies. So if you have a company that serves a customer base that wants a lot of custom stuff, basically they're here. They're making very small production runs of a wide range of parts. The best, the nature of the process that they're going to have, because of the nature of the products that they have, is a very jumbled flow. Okay? They make lots of different stuff. Each product that they make could have potentially a different flow through the process, a different sequence of steps needed to make that product. And therefore, they're going to be here on that product process matrix. And we call that sort of operation a job shop. There's a certain way you set up a job shop, including a layout, and we'll talk about that in just a little bit. But what we're trying to emphasize here is that this is a common place for successful businesses to be. They've got a certain type of customer base, products have certain characteristics, and that means that there's going to be a certain type of process flow, and that means they need to set up their business in a certain way. At the other extreme, you have the business that just makes a lot of a few different things. You get that bottling operation, cranking out sodas or whatever. They make high volumes of just a few different things, and therefore all their products are pretty much going to follow the same sequence of steps of operation. It's going to have a very rigid flow. We call those sorts of operations flow shops, because there's a definite flow for all the products, a definite sequence of steps through which all the products are going to go. Because again, they don't make a lot of different stuff, they make pretty much all similar stuff. So this is a classic assembly line that you see in the movies, or maybe you've actually been on a factory floor somewhere and seen an assembly line. The flow shop can be broken out into a couple of subcategories, and these subcategories are used in the text. When they talk about or when they show, rather, they don't use this term. When the book shows a matrix that looks like this, they have 4 entries, not 3. They have job shop, they have batch operations, and instead of flow shop, they have repetitive operations, and then they also have continuous flow operations. And those are both examples of flow shops. Repetitive operations refers to a flow shop where you have discrete parts, such as like automobiles or bottles of Coke or whatever, whereas a continuous flow shop is a flow shop operation where the product is itself continuous, like an oil refinery or certain stages of steel production. In between these two extremes, the job shop and the flow shop, you have a batch operation, or as I like to call it, a batch flow operation. And this is an operation where there tends to be the flow is in between rigid and jumbled. There tends to be a standard sequence of steps, but not all parts are going to flow through that same sequence of steps. And also, what tends to happen in these sorts of operations is instead of flowing individually, like in an auto assembly line, a flow shop, the cars go individually down the line. In a batch operation, parts move in batches from one operation to the next. So it's not quite as efficient as a flow shop, we'll see, but it has a little more flexibility. It's sort of in between a job shop and the flow shop.